plug in the zeros. What's 1/3 minus a 7? All right, what's 7 21st minus 3 21st? 4 21st? With a pi. There's the volume. You okay with this so far? Hey, just keep in mind, if they say revolve about the y-axis, what are we using? Revolution about the y-axis. We're going to use this one, true? We'll do this for revolution about the x-axis. Should I write it? This is about x-axis. What would be the formula about the y-axis? For the washer method. I heard it. Same thing, but just change this to what?
Y.
Function in terms of y. And function in terms of y. D1s, right? Manual or else. Hey, we don't have to solve it, but I was wondering if you could help me set this up. I'm going to keep that same shaded region at the beginning. Right there. This time, you know where I want this thing revolved around? We revolve this around the y-axis. That same region. Making a bunch of circles in here. What would be the setup? Again, I don't want you to solve it, just set it up. This is dx or dy. dy. This is the outer, this is the inner, right? Look carefully, with your eyes, which one is further away from the axis of revolution? The line or the curve? The curve. So I'm going to put this down, I've got the setup, I'm going to be done. Catch my error, ready? Cool, the curve is further away. Got it. Woohoo! And I move on. I screwed up. What did I screw up? I got to write the curve and the line, but everything's in terms of what? Y. So y equals x, so x equals y, but how would you write this if y equals x cubed? What does x equal? Cubed root of y. There you go. And when that's y to the 2/3 power if you did want to calculate this and do the actual, find the actual answer. Sometimes students are like, wouldn't it give you the same answer? Be careful. It may look like it give you the same. Sometimes it's slightly different. You know, we got 4/21 pi over the last one. 4/21 pi. This one might be slightly different. Oh, so when you do this, if it's about the y-axis, we always got to solve these expressions for the letter x. So that everything is in terms of the variable y. So if y equals x cubed, we'd have to solve for that x variable. Take the cube root of both sides, and you get x equal to the cube root of y. So great question. That's so we get everything in terms of that y. And then you'd be good to go. You'd find that exact value. So we're like, well, what do we got to do for the remainder of class? We know how to handle washers or discs, right? By the way, you can always do the washer method. Ignore the disc method, except if it's a disc, wouldn't this just be zeros? You'd be like top minus bottom. Remember the first one? If in your notes, if you just want to think top minus bottom, always do washer method. Remember my first problem? You'd be like, okay, you're the outer one, and the inner would just be this what? X-axis, right? Some students like to think that way. They're like, I don't want to have too many formulas. So I'll just always do the washer method. Except if it was totally flush with that axis and you're revolving this way around the x-axis, you can think of that as just y equals 0, right? You'll still get the same answer. Hey, so for the remainder of class, we're like, what do we got to focus on? We pretty much hit everything. There's only one thing left for us to do. What if this gets revolved around another line? Okay? So that's what we're going to talk about now. What if this stuff doesn't get revolved about the y-axis, or gets revolved about the x-axis, but gets revolved about some other line? So find the volume of the solid generated by revolving the region bounded, they always say bounded by, the region between y equals x cubed, in which quadrant? Just in quadrant 1, about the line y equals 2. And again, we won't solve, we're going to at least set this up. Because we know with technology, with these cool Pt.3 and equal calculators, we can let that do the definite integral, true? The setup's important to us here. Find the volume of the solid generated by revolving the region bounded by, let's do it again, y equals x cubed. Hey, where did these intersect at? 1?
Yeah.
I'm curious, what's that y value? Is that 1 too? Good. So we're going to roll this around, which line? Y equals 2. So many notes. This is the axis of revolution, isn't it? What's your line of revolution, isn't it? Let me make sure that's flat. We're going to revolve it around that. We got to figure this out. How will we do this? This involves transformation of functions. Do you all remember how to do transformation of functions? This isn't as bad as you think. This is our new axis of revolution. This is it. So I want you to think about this. If this is my axis of revolution, this was y equal to what? X cubed? This was y equal to x? Could you tell me how you would think of those two functions if this really was the x-axis? This got shifted down 2 notches. Do you remember how to write that? What would be this curve? Y equals x cubed, but it got shifted down 2 notches.
Outer.
Minus a what? That's what the function would be. You agree? If it got shifted down 2 notches, pretend this was the x-axis. Then what would we call this thing? X cubed minus 2. What would we call that line? It was y equals x. What would that now be? X minus 2. You agree? These would be the two expressions if you and I, imagine that this was the line y equals x, right? If this was y equal to x, this would be y equals x cubed minus 2. And what would this line be? Y equals x minus 2, right? And where did they originally meet? At 0 and 1. Everyone we now know what to do. There's no trick behind this. Here's the answer to this problem. 0 to 1. Squared. Squared. When it's still only in quadrant 1. It's going around this way, so you all agree it's still dx? Just like the x-axis, so it's still going to be dx. Just be careful. Who's outer? Who's inner? Look at it carefully. Where's the axis of revolution? Here. Who is further away?
X cubed.
This thing, right? The x cubed. So I'll put that one here with the minus what? 2? And which one goes here?
X minus
There you go. And look carefully, what did I forget?
pi.
Alright, don't forget pi. Transformation of functions. This will solve the problem. Now when you only have to set this up, a lot of times, even for a test, for testing scenarios, I have to say set up only. Because I know you could solve the definite integral. You would have to distribute that, right? FOIL it out. Or use your calculator just to compute it. But there's the setup. Cool? Awesome.
Why is it, I'm sorry, I'm a little rusty, why is it not y equals x plus 2? Because don't you want the two functions to move up? Because you want it to revolve around.
I'm with you. I'm thinking that. The reason we're doing an x, it's a difference, is because we were thinking, here's the image we want. We wanted this revolved around this, like you're saying. Like it would look like that.
You want to move that upwards too, right?
Yeah, it's getting shifted around this. So what we have to, the way we got to think is let's pretend that was the x-axis. And then imagine what would these two functions be. That's how we got to think. And if this was the x-axis, both of these two functions got shifted down 2 notches. Now, if it helps, I can give you a little trick that helps. Do you notice in the end, what was this line right here? Y equal to what?
Y equals 2.
Do you notice I just put that number here with the difference? Did you know you could think of that as like a shortcut formula? The only thing is, I want to make sure you tell me what to do. So when you can set up the problem like this, I'm going to give you one word, still from 0 to 1, that's not switching. I was just wondering what you could do, and you could think of this as a shortcut. Ready? This will always be the math formula. But, what if we go around, is everyone ready? I'm going to switch this line, I'm going to put it down here. What if you go around like y equals -3? And all we have to do is put instead of -2s a what? A -3. But when I'm hearing this, what's a minus and -3 become? +3. And there's one other thing I want you to check before I write my answer. Who's further away from this axis of revolution? Who's further away? Y equals x is further away. So I'll put that here. And then I'll put this one here. The only thing is, did you hear this? They said x cubed minus a -3 turns into what?
Plus.
And there's where a plus would be involved. And then this was what? Or if it helps for your notes, just write it like this. X cubed minus -3. X minus -3, because you can think of that as form. And we got one more problem to do. Like, but you covered everything. Well, we're going to end class by revolving around a line like that. Everyone okay? What if we revolve around one of these lines? Let's take that same reading. All right. Let's go around. Everyone, no tricks. Right here. Last problem. This time we're going around the line. X equals 2. Well, I think this is just going to be a shift to subtraction again, right? Does anybody know, by the way, see how that cubed, you know what would happen? If this was the y-axis for this curve right here to do this? You know what that is? You know what it looks like? You know that's what would do it? That's what shifts something to the left or right. You all agree? So that's how we got to think. I'm going to write this down. One of these curves is like this is the axis of revolution. That math formula will still apply. This is by transformation of functions, okay? Put my pi. Where did they originally meet? What do? Everyone, I'm going to have to do dy because it's getting revolved this way, right? So if it's getting revolved this way, we're thinking dy like before, just like the y-axis, okay? So let's get a dy in there. Cool. Who's further away? X equals y, so I'm going to get this here. Squared minus squared. You said the x is further, but I got to put it in terms of y, so this is a y. What was the shift? Minus what? Minus 2 will win it. Just like before. Yeah, so this right here, this was y equal to x before, but because we're going around the line x equals 2 now, you're not going to think of this like, if you're my new axis of revolution, you're not going to think, what would this line be? Wouldn't this line be a line like y equal to like an x minus a 2, right? Something like that. But this will still mathematically work, that we're doing this. The only thing is, what would this curve be? If this was like the y-axis. That would be like a y equals x minus 2, right? What would this be if this was the y-axis? The other one would be a x minus 2 all what? 2? The only thing is, I know I'm going to put this here, I just got to figure that out. Can you all help me figure out this expression? Because it's not just what? I'll put it, then I'm going to put a sad face. Oh, I'm so close, right? You all know this one was further away from this. But what letter do I got to solve for? Yeah, so let's fix it. Yeah. y equals x cubed. What's x equal to? There it is. Got it. I'll put it in yellow chalk. Remember, setup only, so let's just, if you're curious for my test, problems like this, like me, I like to do personally just setup only. So I need these numbers. What were they? These don't change. These are the original points where they intersected, which was what? 0 and 1. But are you okay that I did the -2 -2 on those?
No,
Which each one?
I'm just saying why is the x cubed the outside?
Oh, with this?
Yeah, why? Because if you shift it over,
Yeah, and I want to show you something. So if I had to solve for this x, I'd cube root both sides, wouldn't I? I want you to see why. You cube root both sides of the equation. Like that?
I got it now.
Oh, he sees it. Very good. And then you get this, and look what happens. Very good. Hey, can we talk about a formula here too? Before we leave? Because these get a little weird when you shift. And then I'll go to you. We're gonna get a formula going. What if it's around a line like this? And that line is to the right of these two expressions. We could just put the what? The line down here, minus that number, square both, but this has to be the what? The outer one, which means it has to be what? Furthest away from the axis of revolution, and this one just has to be what? Closer, true? Now, help me out with this. What if the line was over here, like -3? What happens to the math then? Minus and -3 turns into a plus. Cool, oh, go ahead.
Why did you square cube or y?
Oh, yeah, you're awesome. I should have done that. You're the best. Thank you for catching that. That was on video too, thank you. And when he says, I'm going to do the cube root of that, -2, and then this is all what? Great, thank you for catching with your eye. That was a bad error on my part. I give him like bonus point for that. Anybody else see that? You're probably going to be, what is he doing? I have no business squaring it, right? Hey, so is everyone okay with this? And these still say 0 to 1. I like to set up on that only. Cool. Hey, hope the temperature was comfortable enough. And that's it. Great job. If you have any questions, stick around and ask me.
On this, would you be fine if